In this video, we are looking at infinite limits. So consider the function f of x equals 3 over x minus 2. So we're going to write it f of x equals 3 divided by x minus 2. Now, if we look at, say, the limit as x approaches 2. Now, if we plug 2 in, we see that the bottom goes to 0. You get 3 over 0, which is undefined. Now, if that's the case, we don't know how, we don't know what it is, right? So we use a table, we look at the picture, whatever we can do. Analytically, we're kind of stuck, but numerically we can plug values in. Graphically, we can look at it. So if we plug values in, say we get really close to 2, 1.999, 1.99, 1.9, we can see that there's a trend to get a smaller and smaller value, right? -6 is bigger than -30, which is bigger than -300. It's going towards a really, really small number. So we see that it's decreasing without bounds, which means it's approaching negative infinity. From the other side, we want the numbers that are bigger than 2, so 2.001, 2.01, 2.1, 2.5. You see that this one, as we approach 2, the numbers are getting bigger, increasing without bound towards infinity. So this gives us something interesting. If we have a situation where we plug a value in, if that value is a restricted value, which gives us 0 in the denominator, but not a 0 in the numerator, which means it doesn't divide out, then we can say that that limit is actually approaching infinity. It's an infinite limit. Now, our issue comes to whether it's positive or negative, right? And really the best way to figure that out is to look on either side and see. Now, with a situation like this, we see that from the left-hand side, we're going to negative infinity, but from the right-hand side, we're going to positive infinity. Now, remember that infinity is just a symbol, right? It just means an unbounded condition, right? It's just going forever. So it's not a real number, so it's not technically a limit, because we know that for a limit to exist, it has to be a real number, and it has to be being approached from both sides. So in this case, since from the left-hand side we're going down unbounded, from the right side we're going up unbounded, they're not approaching the same infinity even. So here, for 100% sure, this limit does not exist, but the left-hand limit can be thought of as being negative infinity, and the right-hand limit can be positive infinity. So from here on out, we're going to talk about these possibilities of limits being infinite. We're going to allow our limit not to be a real number, but to be that concept of infinity. For the actual limit to be infinity, it has to approach the same infinity from both sides. So let's look at the formal definition of an infinite limit. So here we've got f is some function defined at every real number in some open interval containing c except possibly at c, which means it doesn't have to be defined at the point c. The statement that the limit of f of x as x approaches c equals infinity means that for every m greater than 0, so we're talking about every y value, this is going to be a y value that we call m that's positive, there does exist some delta that's greater than 0, such that the function is always going up whenever we look at this interval around c that is delta width long. So if I pick a point here, then anything up has to be closer. It's always going to be getting closer. That's what this means. This is kind of math speak, but really all it's saying is as it goes up, it's getting closer and closer to c. Now we can also flip this and do it the other way and say if it's going down and there's some n, then there's also going to be some delta here that creates a window, and f of x will always be smaller, which means that the function will always be getting closer to c, and delta will always be getting smaller. Once again, this is kind of math speak. I'm not going to ask you to memorize this, just to recognize what an infinite limit does mean, and it does have to be from both sides. So let's look at this example. We want to determine the limit of each function shown in the figure as x approaches 1 from both the left and the right. So here, if we look at it from the left, it's going up towards infinity. So as x approaches 1 from the left, we know that, that's positive infinity. If we look at the limit as x approaches 1 from the right, so we're coming from the right, it's still going up. Still positive infinity, which means that the actual limit can be written, the limit of f of x as x approaches 1 is going to be infinity. Now on the second one, if we look at the limit as x approaches 1 from the left, so we're approaching 1, it's going up towards positive infinity. But what about if we approach from the right? So we're getting closer and closer. It's going towards negative infinity. Since the infinities are different, that means that the limit as x approaches 1 of f of x doesn't exist. Now let's look at a couple of properties. If we have an infinite limit and then a limit that is an actual limit, if we add infinity to a real number or subtract a real number from infinity, we still get infinity. So adding sums and subtracting sums and differences will always give us infinity if we're adding infinity to some number. Also, for multiplying, if one of our numbers is infinity and one is a real number, if that real number is positive, so if L is greater than 0, then we'll get positive infinity. However, if L is a negative number, then infinity times a negative number will give us negative infinity. Now, what have we said? This is an important thing. If you plug in x, or c, if you plug it in and get, something over 0, not 0 over 0, can't do an indeterminate form. If we have an indeterminate form, that means we need to use something like dividing out, rationalizing, that sort of thing. Here, if you've just got some number divided by 0, we know that's going to be infinity. And we can check out either side of it to figure out whether it's positive or negative infinity, or whether it even exists. If one side goes to positive and one side goes to negative, then the whole limit does not exist. Now, the last thing, our quotient here, what this is going to tell us is that if we get a number divided by infinity, that's going to go to 0. Okay, so not only infinity, but some of those things that we have that are undefined, things like tangent of pi over 2, right? Tangent of pi over 2 is a vertical asymptote, which means it's going towards infinity, which means we're going to have an infinity on the bottom. A number divided by infinity would be 0, right? So this is important. A 0 on the bottom, we get infinity. An infinity on the bottom, we get a 0. So let's look at a couple of examples. 1 plus 1 over x squared. Here, if we plug in 0, we get 1 plus 1 over 0. That's 1 plus infinity, which is just infinity. What if we've got the limit as x approaches 1 from the left, x squared plus 1 over cotangent of pi x. Before we even do anything, let's try to just plug 1 in, because if it's an actual limit, then we know that the left-hand limit and the right-hand limit are the same. We can just we just get that value. So if we plug 1 in, we get 1 squared plus 1 over cotangent pi. Well, that gives us 2 over, what's the cotangent of pi? Well, that's undefined, right? When we get those undefined trig values, that just means infinity. What's 2 over infinity? That's 0. All right, what about the limit as x approaches 0 of 3 cotangent x? Well, if we plug in 0, we get 3 times cotangent of 0, which is undefined, which is infinity. But is it positive or negative? We need to ask that question, right? If we're talking about 0 from the right, then that means we're going to plug in a 0.000, or we can think about the graph. We know cotangent looks like this, right? This is going to be pi over 2. This is pi. This is 0. So as cotangent approaches 0 from the right, so from the right, we're going to positive infinity. So that's 3 times infinity, which is infinity. Now, if you don't remember how these, what this graph looks like, use your calculator. Plug in, cotangent of 0.0001. You can use a very small number that's close to 0 but is on the positive side, and you'll see that you get a positive number, so you know that it's going to be tending towards positive infinity. If you get a negative number, you know it would be negative infinity. Last one here. All right, what if we plug in 0? We get 0 plus 1 over 0, which is going to be 0 plus infinity. But is it positive or negative? Because we're talking about a right or left-hand limit. So since we're talking about 0 from the left, that means that's going to be a negative number. So 1 divided by a negative number is going to be a negative number. So that's actually a negative infinity. So 0 minus infinity, which is negative infinity. Now, according to the theory of relativity, the mass of a particle depends on its velocity, v. Now, consider the following equation where m sub 0, or m naught, is the mass when the particle is at rest, and c is the speed of light. So I don't need any actual values here, but what I want to find out is what the limit of the mass is as v approaches c from the left. So we're looking for the limit of m as v approaches c from the left, okay, of this whole function. M naught over the square root of 1 minus v squared over c squared. So if we plug in c, we get c squared over c squared, which is 1. 1 minus 1 is 0. Square root of 0. Square root of 0 is 0. Something divided by 0 is infinity, right? Now, does it matter that this is coming from the left or the right? Because if this is on the left-hand side of 0, whatever, it's still squared. So, I mean, it's always going to be, this number is going to be a little bit smaller than c, but this is always going to be a positive number to a positive number. We're always approaching 1, right? This number will never be bigger than 1. It'll always be less than 1, because this number on the bottom or this number on the top will always be smaller than c squared. So 1 minus a number smaller gives us a positive number, which is cool. We know it's got to be positive anyway because we can't take the square root and get a negative number. So we get infinity. So the mass approaches infinite mass as the speed of light is approached. So if you have any questions about limits, infinite limits, how to determine whether they are 0, whether they're infinity, please make sure you ask questions in class or shoot me a reminder.